This is where we left off last time, right? We were talking about the objects equals. And we went over this again in the labs. So whether it was Thursday labs or Monday lab, we took some extra time to talk about this equals here. And I'm going to just hit the couple basic things here again. First I'm going to say, writing what equality means for objects is really not as easy as you might think or expect it to be. So if you're looking at or hearing this explanation of equals and you're thinking to yourself, man, this feels like a lot. You're right, it is. But it's a consequence of the complexity of what it really means for things to be equal and how we can check if things are equal. So it's part of it. In this equals, what I want to emphasize, what's important for you to wrap your head around, is this basic pattern. The first 1, 2, 3 checks, casting, and then the remaining checks. Making sure you understand all of the nitty-gritty details, like what's up with objects, is not critically important. It's just important that you can follow this pattern, copy and paste it, and change it for what you need for your other objects as you go. If my explanation is 100% clear, great. If my explanation is so, you haven't quite wrapped your head around it, you're probably fine. And if after the description of equals, you're left scratching your head because you completely don't understand, well, you're going to want to do a little bit more to understand. But if you feel as if you're still a little in the dark after the explanation, that's probably fine. So what's going on here? Okay, public Boolean equals. It overrides a method we got for free, just like in Python with the equals and the repr, like toString as well here in Java. The equals, same idea in Java. We're overriding an existing one, but the existing one checks that sameness thing. It checks if if the two objects are literally the same thing, two references to the exact same one thing. So if they're aliases. This method takes an object reference variable. An object reference variable can reference literally anything. Because if I ask an object, if I ask an apple, I want to be able to say, hey apple, hey my apple, are you equal to this other thing? And if it is, say true. If it's not, say false. So if I give it an orange, or a car, or a banana, I want it to say false. If I were to hard code the type, a new version of Ubuntu is available. Oh, wow. Put that away for now. If I were to hard code the type in there as like a friend, as the parameter, the type of the parameter, I wouldn't be able to give this equals a banana, a car, or whatever in order to say false to. It would just not work. So we use this objects reference variable to say, well, pardon me, object reference variable, because it can reference literally anything of any type. But that reference variable is not overly handy aside from just saying it's a reference. It gives me an ability to have a reference variable to literally anything of any object class. The first thing we check in there is sameness. Before anything, are these two objects, are these two reference variables literally referencing the exact same thing? If they are, stop what you're doing. There's no need to keep checking anything. They're the same because they're literally the same thing. So they're equivalent. Then it checks if O is null. And it's important that we check if O is null because, one, if I say, hey, my apple, are you equal to nothing? The answer is always no because that's a stupid question. But it's important for another part that we'll hit in a moment. So if the things aren't an alias, if it's not null, then we ask, okay, are you of the same class? Are you both apples? Are you both friends? If you're not of the same class, well, you're not equal for our purposes here. Hey, is this apple equal to this orange? No, I really don't need to dig any deeper. It's an orange. They're not the same. They're not equal. Then, if they are equal, if the classes are equal, we can actually start doing the comparison. Because I can actually ask, hey, what's your first name? Because I know if it's of the class friend, it has a field first name, and so on. So we do this thing here, where we take the reference variable O, we cast it as a friend, which is a way for us to tell Java to shut up. Because if I don't cast it as the type of thing that I want, like of the variable, reference variable I want. So other, see the reference variable other, it's of type friend. If I don't cast O as friend, it's going to yell at me because Java can't guarantee, because of this idea of like polymorphism, which we hit way later in the course. It's not critically important right now to wrap your head around. Because friend, other, is expecting to get a friend object, but all it really knows, based on the reference variable, is that O is a reference to an object. But what if that object reference variable is referencing a banana? I can't put a banana in a friend variable. So what I do is I cast it as a friend with that syntax there, parenthesis, friend, close parenthesis, which is a way to say, trust me, Java, it'll be a friend. If it happens to not be a friend, your program will crash. But in this particular scenario, we're actually safe to do so because we've effectively checked and verified that the thing is a friend on line 78. So we know it's safe to cast it as a friend. Great. So all of that code up to line 83 is prep. Now we can actually start asking. This is, I've got 2 apples finally. Now I can actually start comparing the apples. For our purposes, we are checking if the first names, if all the fields match. If the first names match, if the last names match, if the emails match. Now, notice I'm not using equals equals to compare first names, last names, or emails. Because equals equals is a sameness check. Really, it's checking the contents of the memory that the variable is. And when we have reference variables, unless the reference variable is referencing the same memory address, the contents will differ. Equals equals doesn't work on objects unless what you really want is to check, is it sameness? Is it 2 aliases for the same object? So don't use equals equals ever on an object. If I type this into IntelliJ, IntelliJ will even say, no, you shouldn't do this. It'll compile, it'll run, but it'll be like, I don't think this is what you want. Maybe it is, probably not. So what we want to do is use the types, the objects, classes, equals as it is defined. So here we are defining an equals method for the friend class. But now I want to be able to compare strings within this equal method, because I want to check if my first name is the same as that first name, and so on and so on and so on. So the way to do this properly is to make use of its equals method. So I would say something like this. I just created 2 strings here. This is not inside an equals, but I'm going to show how we would use it. I would say s dot equals, right there. Right? And then t. And let's print this out. Let's run it. It's going to say, ignore this top one, it's going to say false because hi and hello don't match. And if I change it to hi, and I hit run, we will see true for the next one, at least we hope so. There. See, hi and hi are equal. So we used the strings equals. Now, mind you, if I go here and say this, it's possible that t is null. And if that's the case, let's run this code and see what it says. False. Does hi equal nothing? No, that's a stupid question. And that's, this check here will be basically in the strings equals method. Because here, again, it should be obvious, we're using the strings equals. And if I control click, this is in the string class, and it's equals. So it's basically got that null check. In this context of how I'm using it here, t is null. So t would become like O, right? that would be the O here because it's the parameter. And if O is null, it's not equal. We've got that check. But we've got a bit of a conundrum here. We've got a bit of a problem. If we put this back, if S is null, we've got an issue. Because in the context of using this, S would be the this, right? S is the reference variable to the object I'm calling equals on. Okay? So that is what this is. It's S and then this point to the same thing. There's no way for me to check if this is null. Because you can only ask something if it's null if it exists. This is going to sound like a stupid statement because it's obviously true, but it's an important statement. I can only ask something if it exists, Like, if I ask you, do you exist? Well, just say yes. I'm pretty sure you do, okay? So your answer is yes, right? You can't possibly say no because by me being capable of asking you if you exist means, like, by default you exist, right? I can't go over and, hey, do you exist? Because you're left going like, you've what? There's nothing over there. You can't ask, there's nothing there. So it's a stupid question to ask. It's a stupid question for an existing entity to ask of itself, unless we get into philosophy, I guess, right? But it's a stupid question. Hey, do I exist? Yes, because I was capable of asking this question. If I go along and ask something that doesn't exist, if it exists, that's a stupid question because it doesn't exist. You can't ask it that. And if you could, it would have to say yes because it wouldn't, like we've got like a paradox situation almost. So the problem is you can't, this method here, it's like S. S can't ask itself if it exists. Because if you could ask the question, it's always obviously yes. But here's the thing, S is null. So I can't ask null if it exists. If I run this, we're going to get a null pointer exception. Null pointer exception. You can't ask null if it's equal to something because null is nothing. So we've got a bit of a problem because really what I would like to happen here is this to say false. No, null does not equal that other string. It worked fine when I asked does this string equal null, but it crashed when we asked null if it equals another string. And we don't want our program to crash in that situation. We want our program to say false. So the trick, the workaround, it's a simple one, but we effectively wrap that equals call, this s dot equals t, we are wrapping that equals call in another function that's just going to do an extra check for us first. And to do that, we say objects with an s dot equals st. There. And if we hit run, it is now a null safe version of equals. Because it'll say false. Now it gives me the answer I want. So this function is providing a way to check if the s slash this is null before making this call. It would be similar to doing like an if statement. If s is not equal to null, right? It would be similar to doing that. Sorry, and then we would go back to s dot equals t. It would be similar to this, what I want to do. So this objects.equals is effectively doing that check for us first before we can ask the object itself if it equals something. And if we ever really want to know what that method looks like, we can control click and go look at the objects equals. Mind you, this is an object with an S. This is a static method, it's a function. And what is this one doing? Well, this here takes object A, object B. The way we used it is that was a string, S and T, right? That's how I called it. So here, first we do a sameness check, because why not, right? Always do a sameness check. Then we have A not equal to null, ampersand, ampersand, A dot equals B. So the A dot equals null is our null check. Hey, A, are you null or not? If A is null, what is the answer to the question? Does null not equal null? Say false. False, of course. Then you have false and something. Do you care what the other thing is? No. False and true is false. False and false is false. It doesn't matter what the other thing is. So immediately after we check A not equals null, if A is null, it returns false based on that Boolean expression. So all of this is to say this objects.equals is a way to wrap. Oh, let me go back one more thing. If it's not null, look what's called. A dot equals B. In our case, A is S and B is T. It literally called the S dot equals T that we were calling, but it just did a null check first. So it's a null safe version, which is good. Any questions? Again. Yes?
General curiosity. What would happen if you do S is null and T is null, but just do the S dot equals T? Because it does check T equals null, which in this case would be true.
So your guess is it will say true.
I think it'll say false because it'll do, actually depends on what the S dot equals actually goes to first. But I'm going to want to say it should say true.
So you are raising a fun question, and let's see what happens. Just because why not?
Because I'm genuinely curious. I don't think I've tested that yet.
See what happens?
Either that or an error. Error.
Error. That's weird. Why did it error? Null pointer exception. String object because S is null.
So it errored before, so it checks if S is a...
Hold on. I want to check what happens
That feels...
if we have... it's got to be a nuance of how the string one works.
Yeah, it has to be something like a slight...
Because let's see what happens with the friends one. The one we wrote. I guess it crashes. Which is interesting, because if we go...
I think what the compiler is doing is it's checking first if S is that object, and since it's null, it's throwing out that null thing before it even goes through the equals thing.
But let's ask the question...
It's like the only way that can happen.
Let's see what happens. See what happens here. If null equals null.
Should be true. Yeah, okay.
So this is true. The problem here is I'm still asking null
If it's equal to
if it's
something.
equal to something.
Okay, so it does end up crashing out way. Okay. That's a
But
curiosity thing.
objects dot equals st will work just fine because if we go in here, so this should say true, false. Wait, yeah, true, because that's the second one.
Yeah.
Because it does this check first,
Yeah.
without having to invoke any method on that value, which is interesting. So very interesting question.
Yeah, I was really curious.
Yeah, it's a fun little nuance there that you pointed out. So the point of all this is, if on a scale from 1 to 10, you should at least understand this at a, let's say somewhere between 4 and a 5, in order to be happy with moving forward. Anything above that, you're probably fine, and you're going to be good. More stuff will get filled in as you go. If you're really screwed on this and you haven't wrapped your head around it, figure this one out. All right, so all of this detail is just going into the detail there. I will say that this is actually incorrect right now, this little note down here. It is possible for it to break, but this just explains basically everything I said. Equals equals is a sameness check. Dot equals is great and all, but it can have an issue with null. This is a way to make it null safe. Hash code. Hash code is another one of those methods you get for free. I'm not going to go into crazy detail on what hash code is and why it's really important. The short answer here is it's very important. We like it, but let's not worry about the details really in this course. The point of hash code is we want to have a mechanism to convert our objects into an integer for whatever reason. There's a good reason, but that's what we want to do. But there's a catch. If two objects are equal, their hash codes must be equal. If two objects are not equal, we really want their hash codes to be not equal. But that's technically not always possible, so the point is, equal objects must have the same objects, same hash codes. Unequal should have different hashes, but not always possible. What we're going to do here, the pattern we're going to follow for this course, at least for these like simple objects, is effectively this. Objects.hash, first name, last name, email. This would be equivalent to doing objects.hash, first name, plus objects.hash, last name, plus objects.hash, email, but we could do it in one call. Additionally, hash code is a method we inherit for free. So, if I were to go down here to s.hashcode, see, it exists. It's there for the string. But once again, this is a null, or not a null safe way to call an object's hash code. Because, well, what if s references null? You're going to get a null pointer exception. So we do the same thing. The same idea exists with the objects, where you say objects dot hash, and then you can put in the thing, and then it becomes a null safe version of the hash code. The amount on a scale from 1 to 10, how much you need to understand this, I'd say is like a 2.5. Anything more, you're in great shape. Anything less, maybe figure out a little more. But this pattern is basically going to be the pattern we're going to follow for all of our simple objects. Writing equality and writing hash code for objects is not generally expected to be an easy thing. But if we follow these patterns, we're going to be fine. Who here started assignment 1? Who here saw that there's a due date for it? Good. And there's also a date for the test, which is the 1st in class. The 1st is a Wednesday. It's in class in here. So there you go. You'll notice, though, that on assignment 1, the equals and the hash code for the country catalog, I gave it to you, right? I gave it to you for free because, yeah, those are a pain in the ass. For the most part, going forward, the pattern you see in the example, in the one I give you, will be the same for all of the collections we write, but I gave it to you just to be nice. What time we got? Great. Any questions about any of the methods we wrote? I'm going to go here, I'm going to copy this. Let's go to our friend. So we've got our equals. We've got our hash. This is our class. I don't know why. Yeah. Public class friend. It's probably saying can be rec whatever. So I'm not even sure what that does. Okay. It's got 3 fields. They're final, which means leave it alone. Constructor that simply assigns the fields. 3 accessor methods to access the values. A toString, because we like toStrings that are more useful than just friend at BF019F. So this is a more useful one. Our equals and our hash code. That's what we wrote. Those are the methods we wrote. simple objects, and when I say simple objects, it's effectively an object that just stores some data for us, are going to look more or less just like this. This pattern is going to become very boring to you soon because you're going to be doing it frequently. If you think, great, that's not too complicated, great. If you're thinking, oh no, I want more complexity, don't worry, we'll get there. All right, so let's create an instance. Well, that's what we would do right here, which we've already kind of been playing around with as we went. Let's go back to lectures. Right? There. But let's talk about what's happening here. So we've got our main. The only real code that takes place in main is friend. A friend equals a new friend, Bob Smith, bsmith@gmail.com. So what's going on? Well, aside from the boilerplate class in main, what's going on? Well, we're declaring a variable for a friend called a friend. We are creating an instance of the friend class. We're making an object, a friend object, who has the fields Bob Smith and bsmith@gmail.com. And then I'm assigning that instance to the variable a friend. Now, I will say, and this is a funny thing because I'm going to point this out because this is true. So, be mindful of what's actually stored in the variable a friend. We have an object here, right? The object is not stored in the variable a friend. A reference to that object. Something like this picture. We've got our variable a friend, and we've got our friend, who's that little waving orange person. And what's actually stored in that variable is a reference to that. The friend is not in that box. It's somewhere else in your computer. What we've stored is a reference to it. The reason I'm bringing this up is because this is how it works, and this is a very important concept to wrap your head around. This idea is not new to you. This idea is how all of Python worked except primitive types. Same thing with Java. Java works the same way except for primitive types, except really it does work the same with primitive types. You just need to be aware of what's actually stored in the variable. When you have a primitive type, the value of that primitive type, like an integer, is stored in that variable, where here, the value is the reference. I will say, I, and many other programmers, will often not specify, a friend is a reference variable to a friend object. Often, I will say, okay, we've got a friend, which is a friend variable, or it's a friend object. That's really not correct, but programmers understand, okay, yeah, but it's a reference variable. So just be mindful of that. All right, so if the following line of code was also run, friend bfriend equals a new friend Jane Doe at jdoe@gmail.com, I would now have two reference variables, a friend and bfriend, for friends, referencing two separate friend objects. I would have two friend objects. I would have something like this figure below. Address of Bob, address of Jane. I'm referring to them by what their first name field is for simplicity. But that's what we've got. And then if we go back up, below is an example of two friend objects being created and used in some way. Not very fun, not a lot going on, but here's what we've got. We've got the two friend objects. We are checking what a friend's first name is, and it's just going to print it out. Then the next two lines, system.out.println a friend and then bfriend. That's just effectively calling the toString of the two objects. And then the last asks if those two objects are equal. So let's copy and paste this code into here and just see what the output is, because why not? I mean, without looking, I would expect to see, Bob, and then whatever the respective toStrings would give me, based on how the toStrings were written. And the a_friend.equals, well, that's false because, Bob and Jane and Smith and Doe and bsmith@gmail and jdoe@gmail they're not the same. Cool. So, this is creating instances and using the instances of the friend class. This is the friend class. what it is and how it works. But you're not doing anything with friends there, unless, you know, the exception would be like, I guess with the equals, because you're using another friend object fields. Here's where we're making the instances and actually doing stuff with them. None of this is new. It worked the same way in Python. The differences are the syntax. In Python, you didn't need the new keyword. In Python, you didn't need to specify the type. In Python, you print it out a little differently. In Python, we didn't use accessors because there was no such thing as public and private. But other than that, it's the same. And I want to make sure when I'm saying it's the same, I'm not being silly. I'm not being like, oh, it's the same as Python, and you're looking at this going like, no, it's not. It's quite different. The syntax is what's different. The general order and what operations you're calling is the same. And that's the important part. All right, so references. As noted above, be careful about what's actually stored in these variables. Objects themselves are not stored, it's references to the object. So in the below example right there, I say bfriend equals aFriend. So this is probably best described with this image. So what this does is it takes the value stored in aFriend. What is stored in aFriend? Who can yell out the answer fastest? Say it louder. A reference to a friend. So we copy over the contents of that variable, which is a reference to some friend. In that case, aFriend is a reference to the Bob one, yeah? Copy over that and put it into B. So just forget what was in B before, just copy over the contents of aFriend and put it there. And the contents of aFriend was a reference variable to Bob. And now the contents of aFriend and the contents of bfriend are the same. They're both reference variables to Bob. So this is what we get. Two variables, they now contain the same thing. If I called equals equals on bfriend and aFriend, or aFriend and bfriend, it would say true. Because the contents of those variables are now literally the same thing. Some reference, some information that gets me to wherever Bob is. And then sad, poor Jane is forgotten about. Anyone know what happens to Jane?
Depends if the thing has a garbage collector or not.
Yeah, true. In Java, what happens is your program goes, well, okay, there now is, assuming there were no other reference variables to Jane, that object somewhere in your computer. Java goes, well, okay, we've got a bit of a problem. We now have Jane somewhere in your computer taking up space. That sounds mean to Jane. She's just a waste of space inside your computer, poor Jane. So Java goes, that's a problem because I have no way of getting to Jane anymore because I have no reference variable to Jane. You have a bajillion memory addresses in your computer. Jane's in one of them, or in a bunch of them. And I have no way of knowing where she is anymore. I've lost track. I'm not going to go search all of my memory to find Jane anymore. So I've lost reference. So Java is smart enough to go, okay, well, Jane's effectively useless, so just delete Jane. There's more nuance involved. Effectively what happens is the garbage collector comes along. The garbage collector is a part of the Java, one of your programs, that comes and looks for objects that exist in memory that don't have reference anymore, and it just deletes them. So they don't waste space. If the garbage collector didn't do that, you would have what they call a memory leak. Raise your hand if you've ever heard the word memory leak before. A couple people. This word was a lot bigger maybe when I was a little younger, because it was more of an issue, I guess, then. It still is an issue, don't get me wrong. But basically, you would have, your computer would be like, well, this memory over here is assigned to that Jane object. And so your program is holding on to that memory, even though it's useless now. Meaning, your program is now just wasting memory. It's got a memory leak. And if you let these programs run a long time that are very leaky, you can end up just taking up more and more and more and more and more RAM on your computer, and your computer crashes. But can't happen in Java. Java has garbage collection to automate that process for you, so we like it. For next time, of course, you're all reading the text, and you can download and play with the friend code. If you click this, and you open it, you will just see the code we just looked at. along with the commented out version of the equals. That's not very helpful. All right, any questions? All right, now, back to unit testing. Who here has missed unit testing? I know I sure did. Put up your hand. Tell me how much you love writing unit testing. Oh, I can't even convince you to lie. Well, you should love unit testing.
There you go.
There you go. You should love unit testing because it helps you write your code so much better than not doing any unit testing at all. So, at the end of the objects review topic, I said, okay, we made an instance and we played with the methods just to check quickly if everything worked. But that is far from a thorough, systematic way of testing that object in that class. That's no good. We want to make sure all the code we write is correct. It's not about having code that is working, it's about having code that is working and we know damn sure that it's working correctly. If you give me an assignment, you're like, I'm done. And I go, but it's all wrong. You're going to be annoyed because you're wrong, even though it worked. It doesn't matter if it ran. It's wrong. It's not about having working code. It's about having correct working code. It's about having well-written correct working code. Okay. So we write unit tests. There's a lot of ways you can test things, but unit test is good because it helps us separate the individual units, the individual pieces of functionality from one another, and we test each of them independently to make sure they all work. We want to test each unit component. These tests can be also run automatically, which is really nice. By writing tests also, it really helps you slow down and think about the funny, different, various cases your code needs to consider. So the process of writing tests might even make you think about certain things about your function that you originally wrote that might need to change before you even run your tests. So the process of thinking about the tests required for your units helps you write better code to begin with, even before you test it. And obviously, it helps us isolate the different components and whether that part worked or that part didn't work and that part worked and that part didn't work. But obviously, the big benefit of the unit tests is, assuming they're written well, they tell you if your code's correct or not. And if it's not, if with really well-written unit tests, it'll tell you what's wrong with your code and under what specific conditions. So then you can go, oh, it failed under this funny situation. Let me go look at my code and find out, oh, it's because I forgot this. So the unit tests, they make you write better code. And imagine for a moment, you wrote your code and you wrote your unit tests. And then a month later, you got to come along and you got to update the code you wrote. You already have the unit tests written. So you update your code, you hit run on your unit tests. 2 fail. Uh-oh, your update was broken. So you write the unit test once, assuming you don't have significant, massive refactoring of the original code, you can write the unit test once, and then any subsequent changes, you just run the same unit test, and it helps confirm correctness all along the way, which is fantastic. So, with Python, we did unit testing with PyTest. No. With unit test was the name of the package we used in Python. In Java, we use something called JUnit. It's a framework for Java unit testing. And it's really simple and easy to write tests. I'd even argue, I'm going to show you the first time and you're going to think, oh man, this is not that easy compared to how I did it in Python. Well, the way you did it in Python on Colab was kind of cheating and you kind of did it a terrible way. And the way you do it in Java is really easy. So this page right here kind of shows you how to do it. But here's what I'm going to do. First thing you're going to do is, if we go over here, I'm going to close this view right here. We have in our project the SRC folder. That's where our code lives. You can have subdirectories as long as they're in the SRC. SRC is your source code. So we're going to make a new folder called test. I'm going to right click on my project, new, directory, call it test. It technically doesn't need to be called test, but it needs to be called test, okay? Great. This is where we're going to put our test code. But before we do that, we need to tell IntelliJ this is where our tests are. So you right-click the new folder, mark directory as test. All of this detail is right here. Create a new directory, mark it as test. Okay? Great. great. I hit the wrong button. There's a test one, but let's do it the old-fashioned way. Right-click, Java class, and then what you do is you call it the name of the class, test. Okay, so now we've got our friend test class. Within here is where we're going to write our unit tests. In order to do that, we need to import all of the JUnit stuff. Now everyone pay very close attention to this. There's a bunch of ways you can do this and tell your IntelliJ project to include JUnit and whatnot. But I want you to pay special attention. The easiest way to add JUnit is to just go type @test. This is an annotation just like that @override we saw. And it's not so much Java code as something meaningful for something kind of outside the code itself. In this situation, you can hover over this, and you'll see that by default it wants to add JUnit4. Everyone look at me. Do not add JUnit4. So do you add JUnit4? No. No. JUnit4 is going to be a problem. It's the older version, and there were some big changes in the versioning that anything we do is going to break. We want to use the new version. So the easiest thing is there, Alt-Enter, and you will see you have JUnit4, then you have JUnit5 point something something. What's actually in that point something something will differ depending on if you have a newer version or I have a newer version than you, whatever. But what's important is that you're using 5 point something. If you hit 4, it is possible to undo that mistake, but it's a giant pain in the ass, and it's honestly almost easier to just make a new project, copy things over, and do it again. So do you add JUnit4? No. Do you add JUnit5? Yes. And then it'll be like, oh, whatever, just, yeah, shut up, add it, great. So now this is telling IntelliJ, okay, add all the stuff that you need for JUnit to work. Because JUnit isn't really a part of Java, it's an external thing that helps us with our Java code. So we have to tell IntelliJ, yeah, okay, add it, great. So I added that annotation. And this annotation here is how we mark a method as a test. So all of this is to just say, great. And you'll even see here in the version, I made this screenshot last year, I think. The version here was 5.7. The version we just imported was like 5.8.1 or something. So, new version's great. So now we're all prepped and we can start writing. In fact, I can go back here and get rid of this. I can start writing my unit tests. So if I click this, we will just download all the tests I have already written for the friend class. But I'm going to copy this first test over and put it there. Oh, and assert equals, whenever you see it yelling about something like this, chances are it doesn't exist yet. You can just do your Alt-Enter. No, why does it not want, oh, does it not? Why is it not letting me import? It's not there, that's why. No, maybe we need like insert true. Let's see if that works. There. I just needed an insert or import. There. Great. I just had to add an import to make it show. Great. So there we go. There is the test. So here, the name of the method is, you're going to look at this and be like, well, that's kind of got like a snake case, camel case thing going on. Yes. This is JUnit method. We want to write these methods in a way that they're very descriptive. So I've named it get first name underscore general case underscore returns first name. And we want nice descriptive method names that follow some pattern, and I'm going to recommend that you follow this pattern where it's unit under test, case, expected result. So if I have a friend object and I call get first name, there's really no other peculiar cases. It's just, okay, it exists. I call get first name. What should I get back? Well, the first name. So what does this unit test look like? Well, we create a friend with the first name, QWERTY, whatever. And then I say, okay, assert equals the string QWERTY, comma, friend.getFirstName. The left-hand side is what I'm expecting, and the right-hand side is the thing that I'm testing. So this right here tests, when I call first name, the friend object gives me the first name back correctly. There. If I run this, see what happens. Test A, all one of our tests pass. Imagine for a second, I go back to the friend, and I accidentally, for whatever reason, did this. I assigned first name the string first name. Okay? So now if I go back here and run these tests, this test is going to fail. Because I passed it the parameter QWERTY, and so when I call get first name, it should give me back QWERTY, but it didn't. It gave me back first name. Then I go, what the hell? I didn't write that code. What's going on here? Why is this test failing? That doesn't make any sense. Let's go look at this. And we go, oh shit, I see the problem. The issue's clearly with the first name field, and I've accidentally assigned it the string first name, not the value associated with the parameter first name. My God. Thank God I wrote my unit test, otherwise I'd be in big trouble. So yeah, the general thing, so the @ says to JUnit, hey, this is a test. I want you to run this when you run your JUnit tests. The assertion is what we're going to assert. There's a bunch of different assertions. There's assert true, assert false, assert equals, assert not equals, assert greater, assert same. There's a bunch. You'll see a bunch. No sense trying to memorize them all because you'll just kind of get familiar with them as you use them. Now, in this particular situation, I've got the get first name. I'm probably going to want to write one for my get last name, get email, my toString to make sure it follows the format it should, and also the equals. Now, the accessors in the toString don't really have interesting cases. I always kind of have that like general case. And if we go look at this code right here, I'm just going to actually copy and paste all of the code. This is going to be mad. I don't even know if it'll import. Hey, cool. Yeah. Okay. So you'll see get first name, general case return first name, get last name, get email. This all follow the same pattern. I've got there's my toString, right? toString follows the same pattern. The only situation that has like a cases that will differ is the equals. Equal friend objects are equal versus equals unequal friend objects are not equal. So the first test there I say A friend, okay, whatever, B friend, and they are equivalent friends. So that I'm using assert equals A friend and B friend. The next one they're different. I call equals, it should be not equal. Great. Now if I run all this, I'm going to get rid of this one because it's not going to work. All of these tests pass. Good. Now, give me 2 more minutes. No, give me 1 more minute, and then we're done this topic as well. The reality is, remember I just ranted earlier this topic about how equality is a pain? Yeah, and testing equality is a pain. And those equals that we did are by no means sufficient. Because what happens if they're different types? What happens if one's null? What happens if another one's not null? What happens if there's a lot of different cases that you'd have to cover. And that, whenever you have different cases, it becomes a lot harder to test. Fortunately, there exist other external dependencies that we could use to test equality for us. And I'm using one, if you go and download, you'll find code that looks like this. You would need to install the external dependencies, which IntelliJ will manage for you. But I use something called equals verifier that just tests equals for me because equality is a pain in the ass. So this warning there is if you go look at that code and you see something like this and you're going, what? It's because equals is a pain in the ass. This won't work by default if you just download and do it without installing dependency, which IntelliJ will do for you, but anyways. All right, see ya.